Adding and subtracting rational expressions is what we're going to do today. And let me just go to kind of the easiest addition and subtraction of rational expressions. Ashley, can you follow this? Put it away. So let me go back to trying to add a couple of fractions. 1/3 plus 5/7. Okay. So when we did this, we got a common denominator. So I need a common multiple for both 3 and 7. That could be 21. That's the least common multiple. So I need to change 1/3 to 21st and 5/7 to 21st. Okay. So what I did was I said, okay, I got to multiply 3 times 7 to get 21. So I need to multiply 1/3 by 7/7. So 3 times 7 is 21. 1 times 7 is 7. The reason that I multiplied by 7/7 is I don't want to change the value of 1/3. So I multiply by the number 1. And that number 1 is, again, I'm going to use 7/7. For the 5/7, 7 times 3 is 21. So I got to multiply the 5 by the 3. So I take the 5/7 multiplied by 3/3 and get 15 21st. Making my answer, now that I have a common denominator, just add the numerator, 7 plus 15, that's 22 21st. Then in algebra class, these got a little bit harder. So let's add 1 over x plus 1 over x squared. That's a good one from Algebra 1. So my common denominator needs to have the x from the fraction in the left, and it needs to have the x squared from the fraction in the right. So if I just put an x squared here, I'd be covering the x squared, and the x squared is also a multiple of the x. The x squared for this common denominator is a multiple of x squared, and it's a multiple of x, because x times something will give me x squared. X times what gives me x squared? X. So all I got to do is multiply this fraction by x over x, and I get 1 times x is x. So I've got x over x squared plus, I don't have to do anything to the second fraction because it was already x squared. And I get, add the numerators, x plus 1 over the common denominator of x squared. So it's this common denominator that's tricky. So let's do a little work with common denominators. So we won't call them common denominators, we'll call them the least common multiple, but we're going to use those least common multiples for our common denominators. So these are LCMs. So the LCM for x and x squared, well, I need to look at the multiples for the x, and I need to look at the multiples for the x squared. The least common multiple can't be x because it's not a multiple of x squared, so it has to be the x squared one. It's got to contain all of the factors of both of the denominators that we're looking at. Okay, let's look at another one. Let's now get to what we're going to be doing today. Let's go 2x squared minus 8x plus 8 and 15x squared minus 60. Well, the best way to find these common multiples is to factor. So let me start factoring the top one here. I can factor out a 2, and this is 2 times x squared minus 4x plus 4. I can factor x squared minus 4x plus 4. Two numbers multiplied to give me positive 4 and add to give me negative 4 are going to be 2 and negative 2. Now, for the second one, 15 will go into both 15 and 60, so this is 15 times x squared minus 4. Oh, x squared minus 4 can be factored. It's the difference of two perfect squares. So this is 15 times x minus 2 times x plus 2. Okay? My least common multiple has to contain all the factors of both of those expressions. It has to contain two. Negative 2 times positive 2 is negative 4.
Right, but isn't it a positive 4?
Isn't what a positive 4?
In parentheses, the 2 times x squared.
Oh, thank you. That should be x minus 2 times x minus 2. Thank you. Jeez. Thank you. All right, we need everything that's in the factoring of the first expression. So 2, x minus 2, I need both of those. If I've got 2 of them, I need 2 of them. And then everything in the second expression. So I need the 15. I need a single x minus 2. I have a single x minus 2 already, so I'm okay. I needed the 15. I have the x minus 2 already. Oh, but I need an x plus 2. So when you're finding these least common multiples, you don't have to repeat from one expression to the other a factor you've already gotten written down in the least common multiple. Let me simplify this. 2 times 15 is 30. X minus 2 times x minus 2 is x minus 2 squared times x plus 2. There we go. So I didn't need to repeat that x minus 2, but I did need to repeat it in the first place because there were 2 of them on the first expression. So I needed both the x minus 2s, but I didn't need 3 of them. Yes, ma'am.
Say like it was 15 times x minus 2 times x minus 2, then would you just leave it as 2 times x minus 2 times x minus 2? Or would you have to put
Do I,
like say you've got 2.
oh, okay, so you're saying suppose we didn't have this x plus 2 over here in the green? Suppose that was an x minus 2. All we need is 2 of them. So so if this green x plus 2 was an x minus 2, I'd already have 2 x minus 2s down for my least common multiple, so I'd be fine. That's all I'd need. Good. Okay. So let's use this concept to do some, we'll do an addition and then a subtraction. So my addition is going to be 1 over 3x squared plus 21x plus 30 plus 4x over 3x plus 15. First thing I do is I factor the denominators. So the fraction on the left, I can pull a 3 out. So this is 3 times x squared plus 7x plus 10. So plus sign there. And I can factor x squared plus 7x plus 10. That is x plus 5 times x plus 2. Okay.